Radio waves have been the backbone of space communications for more than half a century. But as space missions generate exponentially, more data transmission is required. At the same time, we are reaching the limits of what radio can handle. That's why engineers are now looking to harness the power of laser beams and offer a solution to the growing needs of space communications. Laser communication, also called as optical communication or free space communication, uses modulated laser beams to send and receive information wirelessly between 2 points. By encoding data in laser light, which has much shorter wavelengths than radio, more information can be transmitted per second. NASA and other space agencies have begun testing laser communication technologies, paving the way for an operational transition in the coming years. From arrows of light crisscrossing satellites to future astronauts downloading data at gigabits per second. In this video, let's look at how this transformative technology will soon revolutionize space communications. Welcome to the channel, Get Smart. Why do we need laser communications in space? NASA uses lasers to send information, employing invisible beams to traverse the skies, sending terabytes of data, pictures and videos to increase our knowledge of the universe. But the important features to use laser communication includes its higher frequency, smaller and lighter optical systems, less power consumption and improved security. Now let us look into these features. Higher frequencies. The laser light operates at higher frequencies, about 200 terahertz, compared to a few gigahertz for radio waves. This enormous leap directly leads to significantly higher data rates, as more information packets can be encoded into the higher frequency carrier beam per second. Smaller and lighter optical systems. Laser light is the miniaturization of hardware for space communications. In contrast to radio antennas, laser transmitters and receivers are smaller and lighter due to their shorter wavelength. This weight reduction is critical for spacecraft because it impacts launch cost and mission flexibility. For example, NASA used a 70-meter-long Deep Space Network satellite dish for transmitting radio signals. At the same time, NASA's Lunar Laser Communications Demonstration (LLCD) achieved high-speed communication using a small 0.5-watt laser and an 8-centimeter telescope. Less power consumption. RF signals require high transmission power for long-distance, high-bandwidth connections. In contrast, the focused beams of laser communication minimize energy waste from spreading or absorption, providing greater efficiency. Improved security. As radio signals are widespread, they are vulnerable to interception and interference. The fact that laser beams are precisely directed along a narrow path makes them extremely resistant to hacker attacks and sabotage. Now let us see how new laser communication mission will work in space. Laser Communications Relay Demonstration (LCRD), NASA's first two-way laser relay system. The LCRD represents a transformative technology with the potential to revolutionize spatial data transmission. LCRD uses infrared light or invisible lasers to send and receive signals, potentially allowing 10 to 100 times more data in a single transmission. LCRD has two optical terminals, one of which receives data from a spacecraft and encodes it into laser beams. The second terminal then transmits the encoded data from the LCRD to ground stations for analysis by scientists. The ongoing LCRD experiment assesses the feasibility of the technology for future missions and tests laser transmission capabilities in orbit. Next, we will see about ILLUMATI. ILLUMATI stands for Integrated LCRD Low Earth Orbit User Modem and Amplifier Terminal. ILLUMATI was launched and it was installed on the International Space Station. ILLUMATI transmitted high-resolution data to LCRD at a rate of 1.2 gigabits per second. ILLUMATI will relay data from the space station to LCRD, Then LCRD will send the data down to optical ground stations. Once the data reaches these ground stations, it will be sent to the LCRD Mission Operations Center. After this, the data will be sent to the Illuminati Ground Operation Team. There, engineers will determine if the data sent through this end-to-end relay process is accurate and of high quality. Now comes Terabyte Infrared Delivery, T-Bird. The T-Bird payload is part of the Pathfinder Technology Demonstrator 3 mission. T-Bird showcased 200 gigabit per second data downlinks during its operational period, the highest optical rate ever achieved by NASA. The tissue box-sized T-Bird satellite has paved the way for future deep space missions that can transmit large amounts of data back to Earth. Now comes Orion Artemis II Optical Communication System, O2O. The O2O will bring laser communications to the moon during the Artemis II mission. O2O will be capable of transmitting high-resolution images and videos. Artemis II will be the first crewed lunar flight to demonstrate laser communications technologies sending data to Earth with a downlink rate of up to 260 megabits per second. Deep Space Optical Communications. This groundbreaking DSOC technology riding on the Psyche spacecraft harnesses the power of lasers to unlock the secrets of the cosmos, from high-resolution images of distant worlds to the composition of mysterious asteroids. The DSOC transceiver integrates advanced technologies including a photon counting camera and a telescope for precise laser tracking. This project will address the growing need for high bandwidth data transmission in space missions to advance communications technology for future space projects. While fiber optic technology reshaped terrestrial communications in the 1990s, free space lasers are poised to take the next big step in transmitting our information beyond Earth. This transition will usher in an avalanche of missions powered by exponentially higher data from across the solar system, fundamentally changing the way we connect to space itself. Laser communication is an innovation that will be a huge part of the space industry in the coming years. Thank you.